Hello, good morning, everyone. Um, welcome to another advanced networking lecture. I have some more students joining in, but let's begin. So, the topic that we discussed last week is about switches. We discussed about switch networks and so the basic, or rather, the key functionality of having switches and things like that. So today we are going to continue that topic and discuss a bit more about uh, switch networks, and also then talk about how switches are configured, or some of the key configuration aspects that we have when it comes to switches. So the actual configuration part you will be able to do them in the with the practicals to the corresponding lesson. But we will go through the basic, the overall things that we will need to do regarding configuration. So when we are talking about switches, we are talking about layer 2 networks. So with these layer 2 networks, uh, there are a few design guidelines that we have. So again, we discussed this last week as well, having this three-layered architecture with a core layer, distribution layer, and access layer, with the lowest layers particularly being layer 2 devices, switching devices, and the upper layers being able to do routing capabilities, having routing capabilities as well. Then the distribution layer, again, we talked about there's a possibility that we can combine distribution and core layer in certain circumstances. But if we have a number of different buildings and so on in such a architecture, and in that network design, we are more likely to have a three-layered structure. And one of the other considerations that we will think about when we think of switches is the proximity that they need to be to the end devices. So to the users, whatever the devices that they are connecting to, we are ideally, we would like to keep them as close as to those end devices, end users as possible. This could be due to the limitations that we have with different sort of connectivity mechanisms. Say, for example, if you are using Cat5 cables, the ideal distance is less than 100 meters. Even for Cat5e, Cat6, it's still around 100 meters. We rarely go beyond that. And even in a practical sense, with the way cabling and all would be done, normally 80 meters is a sort of a practical maximum people tend to keep. So with that scenario also, we need, that's one of the other reasons why switches are so much spread across larger premises, for example, why we don't have a single switch catering from a single location. It also has the other advantages of not necessarily needing a lot of wires connecting back and forth. So there are those things as well, but also certain technical aspects also contribute to that decision or that scenario. Then another aspect that we would focus when we are thinking about layer 2 network design is about minimizing the path distance between elements. So when we take a number of nodes in our network, uh, let's say we are connecting from node 1, we are looking at connectivity from each node to the other sort of thing. So if we think about node 1 to node 4 in this case, it's a connectivity of going through 1, 2, 3 hops if we go with the understanding of hop distances. Whereas in the other arrangement, the maximum we have is 2 hops. Say for example from 2 to 3 or 2 to 4, we will have 2 hops. So with our overall design, this is also something that we would want to achieve. Minimizing sort of cascaded paths of network. So that minimizes the likelihood of a larger portion of things failing. Say for example, if we take in the structure, if one of these things fails, all the devices attached to 2, 3 and 4 are also now disconnected. Whereas in the other scenario, if one of these link fails, only one switch will be affected. So that is also a reason why we would want to minimize path distances between elements in our switch networks. So when we think about building these type of switch networks, we would like to build them in an incremental manner. Say for example, if we take, let's take a university for example, we can take our faculty. So in our faculty, we have about 5 or 6 main buildings, building structures. We have about 5 or 6 of those. And in a number of those, we have a number of floors. So the admin building has about 3 floors, academic building has about 4, 5 floors, lecture halls building has about again 4 floors, lab building has about 5 floors, 6 floors. So we have different, all of them are somewhat larger buildings, and there are also other couple of smaller buildings. So what we would prefer to do when we are designing these networks is we would start from one of those buildings, and even within those buildings we would ideally start from a single floor, and depending on the scenario, even within the single floor we may go to number of sections. Say for example, if we take the lab building in our university, in our faculty, there the switch network, the switches are placed in a manner that each switch distribution switch box will have a couple of switches connecting two labs. Then all of those the two labs are the only points that are connecting to those switches. Say for example, in an area where staff offices are located, there a single flow may be able to connect to a set of switches. So that also depends on how many end devices we are expecting in a particular area. So then once we have that, we will go to the next level. So this diagram shows the actual network design for our faculty. So what we have is we start with a number of switches distributed across different areas within the faculty, different buildings. So each of the sort of columns that we have are individual separate buildings. So once we have them, these switches, then those are connected up to the next level. So in this setting, we are going with a fiber option. So what we have is we'll have the switch with the local connection. Then from there, we go with the fiber uplink to aggregation switch. So such an aggregation switch can be there depending on if there's a need, or we can have that as a distribution switch as well. So they would function in a similar manner. So in our case, we have a number of distribution switches for each of the main buildings, and each of those distribution switches are redundant as well. So we have redundant connectivity from that point onwards. And then when we go further up the layer, those switches connecting to the distribution layer, they can further uplink to the core switch layer. So again, if we go into our scenario, what we have is we have distribution switches for each of the buildings. So all the buildings are connected back to the main admin building server room where the core switches are located. So all of them have redundant fiber paths going through two different pathways, physical pathways. So they are not going together. They are going from two sides of each building, and they are going. One is going from building to directly to the admin building. One is going through a perimeter, like a loop, a ring loop. Then there are also direct connections between each of the buildings, creating a sort of another layer of a cascading or linking between these individual buildings. Then at the admin building level, we also have another set of aggregation switches that are connecting some of the other services like IP phones and cameras and other servers and things like that that are mainly located within the server room. So that aggregation switch is mainly for that purpose, connecting things within that area and then connecting them also to the core switch. And again, at the sort of switch network level, so even at the physical layer, we have a number of different varieties happening here. We have different types of fiber cabling. Some of them are outdoor fibers, some of them are indoor fibers, depending on where they are placed. And then, say for example, the admin building distribution and admin building core are connected through indoor fiber, whereas other buildings are connected through outdoor armored fiber. Then we have other switches connecting back to distribution, again using they are again fiber backbones, but they are much different types of fiber because again our need is somewhat different there. So this is the interconnectivity of switches that we have at the technology faculty. So once you probably, we have most of these things in place. Some of the core switches are still not there with us, I think. So this is where we add the redundancy pathways. So when we take to the next levels, again we saw about the possibility of having these redundant links. Again, wherever possible, we will add a redundant link. So even in our case, we don't have redundancy at the lowest level. So that is when we are connecting from access switches to the distribution layer, that connection doesn't have redundancy in our case. Whereas from that point onwards, from between distribution switches and also distribution switches to core switches, we have redundancy. So depending on our needs, and again, adding redundancy is also sometimes a costly affair. So that's, and sometimes in certain scenarios, it's not particularly needed as well. So we'll have to make those type of judgment calls as well. So we will normally add redundancy at these upper layer switches. One thing that we would always want to avoid in our network designs is the type of daisy chaining that we may see in certain environments. Because sometimes it's much easier to connect, say, let's say even in our case, if we look at these buildings physically, like say, for example, these 4 buildings are sort of organized in this order. So actually speaking, the connectivity between, say, admin building to academic building is much shorter, whereas admin building to laboratory complex is much longer. So if we go through sort of a cascading manner, it would be much easier because we don't need to lay longer cables going through all these places. But that is something that should be avoided. That's not at all a preferable solution, because that can lead to very bad failures in our networks, because that lead to some significant single point of failures. If a single link fails, all the rest of the network that is under that cascade is going to fail. So that is one of the main reasons why we would always want to avoid um, cascading our network. So that is something that we would not prefer to do in our networks. So when we are connecting buildings, again, the preferred way of connecting building is connecting them in a hierarchical manner. So we have a single building, and for each building we try to aggregate them to a single point. Once aggregated to a single point, then we connect them back to next level. So say either, again, it could be a distribution, it could be a core, depending on the size of the buildings and the nature of the design. But we try to go through this hierarchical design. So again, the same thing that we have here, we aggregate them at the distribution switches at each of the buildings. Then we are hierarchically connecting them back to the admin building core switches. We have some of these redundant links connecting in between them, but they are not technically cascades. They are, because we also have the hierarchical links. These redundant links are mainly there for as sort of a fail-safe option, rather than they are not the option. So them failing or other failures, they have much more tolerance to address or manage those scenarios. So then when we think about switches, we also have another type of switches that we may come across are unmanaged switches. So the switches that we were mainly talking about so far are managed switches, where we can go into those switches and uh, uh, do certain configurations and things like that. But then there are certain switches that are known as unmanaged switches, where we don't have any configuration possible. They will use the basic switching mechanism to do the switching. So they will work under the IEEE 802.3 switching, which is the basic MAC address based switching with a simple switching table. So they will do that type of switching without any configuration. So you just plug in a device, it is part of the switch network, and it will work like that. So we will not be able to use these switches if we are building redundant configurations, because otherwise it will lead to loops and things like that. So we will only be able to use these in very sort of limited scenarios. They have their places, but their use would be very limited as to what we can do with them. Whereas managed switches is the main type of switch that we are talking about. So these are the ones that have the capability, or that will give us the ability to control various things regarding the communications that we have. So we will be able to one, manage the switch itself, like that is configure the switch, monitor what is going through the switch. So we will have the ability to do that. That's one part. Then also we can, when it comes to configuration, we can configure a number of things, like if we need to use VLANs, we need managed switches. If we need to use quality of service QoS for certain traffic prioritization, like VoIP services, video services, and things like that, again we need to have managed switches. Then if we need to build a redundancy in our networks, or port mirroring or multicast, so all these things we need to have managed switches. Then only we can enable these things. And also for many of these capabilities, switches also need to communicate between them, or some configuration needs to be shared between switches. So to achieve those things, um, we would need managed switches. So as someone asked, like whether we can use unmanaged switches at the access layer, yes, there are certain circumstances where access layer, or rather unmanaged switches, can be used at the access layer. But then again, if we are still needing to use VLANs, then that could be a problem. Say, if we take, for example, okay, let's take Yeah, that's correct. I'm having some trouble putting the diagrams there. So the thing is, say for example, if we have, say, if we use IP phones, let's take that as a simple example. We use IP phones, and normally what we do is IP phones and whatever the computers are normally within available in the same area. But we need to identify these two devices into two different VLANs. Normally, IP phones are on a different VLAN, and the normal LAN connection, the normal computers are in a different VLAN. So those ports needs to be identified with those particular VLANs. So to do that, we need to have managed switches. So if we don't have in within that access layer, we don't have any differentiation between the devices that we have there. All of those things are the same thing. Then having a managed switch, or rather unmanaged switch, may be possible if we add the VLAN tagging at the next level. Uh, so or if we are thinking about a very simple network where we don't have any VLANs, we don't have use many of these functionalities or capabilities, again an unmanaged switch may be fine. But in other cases, we would need to have some aspect of managed switches, because they will give us certain advantages, certain capabilities. So beyond these managed switches and unmanaged switches, which we are mainly talking about as layer 2 switches, we also have layer 3 switches. So layer 3 switches are switches that have some routing capabilities. So they will perform the whatever the routing functionalities that we have studied earlier when we were discussing about routing. They will be able to do those things. Any inter-VLAN routing or routing between different networks, they can be done with those layer 3 switches. So again, if we look at our faculty network, again here what we have at the core layer is we have two core switches, and these two core switches are the ones that are going to do the routing. We will talk about OSPF routing later on. So we will be using OSPF, and routing will be done at this core switch layer. And then we will have an ISP router connecting outwards to the internet, and we'll have firewalls and few other things that are not included in this diagram. But essentially, the core switch, the layer 3 core switches, are the ones that are going to do the internal routing for this network. So it has become very commonplace to use these layer 3 switches for routing purposes, because we don't necessarily need a router, or in a way they provide some of these routing capabilities. So it's a bit of a not a gray area, but we can do both with the same device, so, sort of a thing. Okay, now let's sort of briefly go through some of the points about configuring switches. I will not go into a detailed explanation of actual configuration steps, which you can try out in your practical lessons, in your practical activities. But we will go through some of the key things that we need to keep in mind, we need to look for when we are configuring switches. So if we are talking about physical switches, one of the things that we will come across is the actual blinking lights and all that. And depending on, again, this would vary from manufacturer to manufacturer sometimes as well. But these are fairly common standards across vendors. Um, you will be able to you'll be able to see certain things about links, whether the link's active, links up, or anything is connected. So those type of things we will be able to see. So that is sort of the first level of troubleshooting we can do, is to see if things are connected by looking at the actual physical connection, because only when we have the physical connections up and running we can start thinking about the configurations and things like that. So to configure a switch, we need to go into the configuration environment of a switch. So this is somewhat similar to how we may configure one of the like Cisco routers and Cisco switches. At the operating system level, both of them have the same operating system, the iOS operating system. The device that is the underlying operating system on the device. So many of the configurations and things are fairly similar. So one of the things that you can do is, like, say, many of these switches are able to reconnect and go back to their states how they were before, so they can go back to their previous state. But you can normally, like the configurations are stored, so you can normally go back and it can automatically come back from those things. So when we talk about these things, the first thing that we need to do is we need to have some way of connecting to our switch. So one way that we connect to switches is many switches will have what is known as a console port. So we will connect to the console port of the switch, and then we will connect that to our computer. It may be through some interface that we may have. We connect to that, and then we can configure from that. So this will be like a direct console connection between the computer and the switch. So we'll have to set up the IP address in our computer side. We'll have to set up the IP address that would be corresponding to that console port and in that network, so that we can manually. So it's like manually setting up devices in a network type of scenario. Another approach that we have is actually using the IP network. So the switch is connected to the networks. So we can have one of the interfaces. We can have a virtual switch interface available to us to configure, and that will be part of the IP network. So we'll have a connection that we can come through our router, as with any other network. We will come to that, but we'll normally have it on a separate VLAN. So we'll have it on not the usual VLAN, but we'll have it on a management VLAN. So all the management related connections only can go through this switch virtual interface. So we can make some controls and have some security around this as well. So with the configuration steps, there are a few things that we may do. One is about configuring. So if we have a management VLAN that we have, so then we need to put that SVI or the switch virtual interface into that management VLAN so that we can make that connectivity. We need to configure that interface. Again, it needs to be given an IP address and a subnet mask. And we also need to give the default gateway corresponding to that, so that switch can connect to that device. Rather, that switch can enable the connectivity back to the router. That particular SVI can make that connection, so that we are able to get through to that SVI. So then when it comes to certain physical layer aspects, say for example, sometimes the physical layer, there could be certain differences in terms of whether they are duplex, they are full duplex, half duplex. Are there anything like that? Are there any sort of certain speed considerations for these links, whether it is a 100 link or a gigabit link? So things like that. So those are also things that we will be able to configure for each link or each port. So that is also something that we will be able to configure by going into a particular interface, and then we can set that interface as a full duplex interface or a half duplex interface and set its speed. So we can set those things as well. So again, this may not be necessary in all scenarios, but if we have certain mismatched speeds between two switches interconnecting and they are not able to negotiate those things for some reason, we can configure those as well. But in most cases, most of these days, we have what is known as auto MDIX, which is something that will be able to do these. We can set these configurations to happen automatically. So whether it is a duplex connection, that can be configured automatically, whether the speed can be configured automatically, and also whether it is a crossover connection or a straight through connection, that can be configured automatically as well. So so are you familiar with crossover connections? I think you would be from your previous courses. So if you are directly interconnecting to these devices, that negotiation will happen automatically to determine whether it is a direct connection or a straight through connection or a crossover connection. So I would suggest that you try out in your practical activities. So these are some of the commands. Again, many of these are also fairly similar to what you may have come across with routers, because both of these, in this scenario, both of the Cisco devices, the routers and switches, particularly regarding configurations and saving configurations and things like that, have or share similar commands. So that's something that you can try out. Then, in addition to actually looking at the physical bulbs of the switch to see if a link is up, a link is working, and all that, we are also able to go and see within the switch how that has been detected. Say, for example, if we go into a fast Ethernet interface and see what is the state of the interface with the show interfaces command, we can see whether the line is up, what is the MAC address, what is the speed, and all that. We will be able to see there. So that is also something necessary, because not in many cases we will actually not be able to see the physical LED indicator bulbs on switches, because switches may be in racks, and the racks may be somewhere else or somewhere higher up. So we are not always going to climb and see what's the situation there. The most likely scenarios we will go through the configuration interface and see if there's any issues. So this is a basic troubleshooting step when it comes to access layer networks. So one of the main issues that we encounter at access layer networks is about issues with physical cables. Um, the physical cables are not connected properly, the physical cables are damaged, or the interfaces are damaged. So those are the main issues that we may encounter when it comes to access layer networks. In addition to this, sometimes we may also encounter things around mismatching speed configuration, mismatching duplex settings, and things like that are also possible. So again, all of these things we will be able to check and verify and troubleshoot using some of the basic commands like show interfaces, and we can go and identify if things are as we expect them to be. Then one of the important things that we need to remember when it comes to switches and configuring switches is uh, how secure are we able to make this whole process. So telnet used to be a protocol that we used to connect to these devices, to configure these devices and so on, but it is no longer preferred and no longer suitable in our environments, because it is an unsecure plain text communication protocol. So ideally, we would like to use SSH, so coming through an SVI in a management VLAN, coming through to the switch through that, and connecting through SSH, and then communicating. So that is what we would prefer to do when we are particularly when we are thinking about the security of the communication. And so one is having the SSH communications, and then also when we put these management connections, management communication in a management VLAN, and then we make certain restrictions about who is able to get into that VLAN. So using these number of these approaches, we will be able to make certain secure environments in this regard. So when we are able to set up secure connections, then it enables us the opportunity to connect from anywhere from that IP network. Sometimes even from outside the physical network is also possible if we allow that through our firewalls and things like that. We may even be able to allow such things if that is needed. Because like again, the main thing about security is like you don't need give things that is not needed. So if it is needed, we can allow that possibility as well. But otherwise, we can go through an SSH configuration and connect using that to our switches. Then another important thing that we can do in terms of security in switches is if our switch has certain ports that we know are not needed. Say, for example, in an office environment, if all the office devices are wired properly, everybody has a particular device and IP phone connections and all that are set up. And after that, say we have about 5 or 6 ports left unused in our switch, it is best if we can go and disable those ports. Otherwise, somebody who can physically get into the space can plug if it is Ethernet, plug an Ethernet cable to that port and then try to get into the network. They may be able to do certain things. So what we can do is, if we go into those interfaces and if we can shut down those interfaces, we can disable those interfaces when they are not in use. That also avoids a particular level of security concerns. Then if that is needed again, we can go and start that again. We can enable that port again. Then another thing that we can do at a switch level in terms of security is uh, known as port security. So again, here what we do is, if we know a particular port is always connected to, say, an IP phone, so we expect only that IP phone to be connected to that port. So then what we do is, we only allow that IP phone uh, uh, only allow that IP phone to be connected to that port. Say, for example, so if we organize it in such a manner in in an office environment, say somebody goes and removes an existing IP phone connection and tries to put their own device and try to get into the network, again that will not work, because that port is actually connected only to receive connections from that IP phone. So that is another layer of security that we can add. So with this port security, again, we have a number of approaches. One is, we can go and manually configure these ports, each of the ports, and say what is the allowed IP addresses for that particular port. Or we can have a dynamic MAC address process where the first connected device will be accepted, but after that, only when the switch restarts, a new device will be accepted. So that as long as the switch is switched on, that will not be you will not be able to add a new device. Then we have another variant to that, the sticky MAC addresses, where it will dynamically learn the first device connects to the port will be added to the configuration, but after that, even if the switch restarts, um, um, only that same device will be accepted. So these are some of the additional security measures that we can take with using of switches. So again, with port security, we can have certain different things as well. Uh, when some violation happens, say if we have put in port security and we have configured this MAC addresses or through sticky configurations or whatever, and after that, if somebody comes and changes one of the devices, we can do few things. We can allow uh, whether we allow the traffic to go through or whether we stop the traffic from going through. So there are few different things that we can do in terms of that. So that's also another aspect of when we think about switches. So not just in addition to configuring switches, one of the things that we can look at is what are the security implications that may come from these switches and how we can address that. Because again, switches are going to be mainly the devices that are more vulnerable for physical exploitation, because they are most likely to be located in places where other users are more easily can get in. So even in the case of a university, the switches in a laboratory environment or like in these places, they will be located inside a laboratory, for example, which is much more accessible than a server room, which will be inside a much more closed off environment. So somebody randomly walking into that space may not be practical, whereas a switch rack in a laboratory building or something like that would be much more accessible. So that is also a reason why thinking of these type of security aspects could be important as well. So with that concludes our discussion on switch networks and switch configuration. And we will continue discussing about VLANs next week. So some of the questions that you had about VLANs, we will discuss about them in a bit more detail next week as well. So are there any questions on things we discussed today? I think some of you already asked some questions on chat. So if there are no other questions, we may conclude the lecture session now. And so if that's all, we may conclude for the day, and we will continue next week around same time. Thank you.